welcome back to my class. In the previous video, we learned about echo. Did you remember that? Yes, it is the phenomenon of hearing a sound by reflection from a surface or obstacle after hearing the original sound. And today's class starts with a new topic, that is acoustics of buildings. So let's see what is acoustics of building. Students, haven't you seen that walls are rough surfaces in big halls like the cinema theatre? Can you say, why are the walls made rough? Because it allows only direct sound to reach the audience. Cinema halls and auditoriums are carpeted and the walls are made of rough materials because these materials absorb the sound and do not allow them from going out of us. Sometimes the sound can be a trouble to the people. That means the walls are made rough to avoid the regular reflection of sound. Rough surfaces can absorb sound. If the distance between the walls in a room is more than 70 meters, the sound waves are reflected repeatedly from the walls, ceilings and floor of the hall and produce many echoes. So the sound becomes blurred, distorted and confusing due to overlapping of different sounds. So for increasing the audibility in halls, we can do the following things. Use curtains having many folds. Provide large number of ventilators and windows. Make the walls and roof rough. Make sure that the ratio between the height and width of the hall 2:3. Make the floor rough using carpets and increase the number of audience. So let's see the definition of acoustics of buildings. It is the branch of science that deals with the conditions to be fulfilled in the construction of a building for clear audibility. Students, let's learn about Whispering Gallery. The Whispering Gallery at St. Paul's Cathedral in London is the best example for the sound getting reflection. Even if you are just whispering near the circular wall below the dome, the sound will be heard loudly everywhere inside the gallery. This is due to the multiple reflection of sound from the circular walls. The Gol Gumbaz in Bijapur of Karnataka is another example. Our next topic is ultrasonic sound. Sound with a frequency greater than 20,000 Hz, that is above the higher limit of audibility, is called ultrasonic sound, that you already studied on your 8th standard. So let's see the uses of ultrasonic waves. We know that ultrasonic sounds are waves. So ultrasonic waves are used to clean spiral tubes, machine parts without a definite shape and electronic components. Objects to be cleaned are dipped in a cleaning solution. Ultrasonic waves are passed through this solution. Due to the high frequency of vibration of ultrasonic waves, dust and grease-like substances get detached and are removed from the object. Second one, ultrasonic waves are used to detect cracks and flaws in large metal blocks. Ultrasonic waves passed through a metal block are allowed to reach the detectors. If there is any crack or flaw, ultrasonic waves will reflect back from that part. So, they do not reach the detectors. Audible sound waves of longer wavelength cannot be used for this purpose as they bend around the corners of the defective location to reach the detectors. Third one, echocardiography. Ultrasonic waves are used for taking images of heart. This is known as echocardiography or ECG. Fourth one, ultrasonography. Ultrasonic waves are used for getting images of internal organs such as kidney, liver, gallbladder and uterus. Ultrasonic waves travel through the tissues of the body and get reflected from the region where there is a change in tissue density. These waves are then converted into electrical signals and are used to form images of the organs. This technology is called ultrasonography. Ultrasonic waves can crush small stones formed in the kidney into fine grains. Next one, sonar. Sonar means sound navigation and ranging. Sonar is a device that uses ultrasonic waves to measure the distance, direction and speed of objects under water. In the figure, ultrasonic waves are sent from a sonar which is installed in a ship and they get reflected back after striking an object at the bottom of the sea. So let's learn what happens to the ultrasonic waves after striking the object on the seabed. Ultrasonic waves that are reflected back after striking the object reach the detector. The detector converts the ultrasonic waves into electrical signals. The distance traveled by a wave can be calculated by knowing the speed of ultrasonic sound in seawater and the time taken for the wave to return. That means distance equals speed into time. Bats make use of ultrasonic sounds for catching prey. So let's see, how do bats catch prey? Bats produce ultrasonic sounds and the sound gets reflected after striking the prey. It can receive the waves. So let's learn the next topic, seismic waves and tsunami. Seismic waves are those waves of energy traveling through Earth's layers as a result of the earthquakes, man-made explosions and volcanic eruptions. Seismic waves are originate from the epicenter of the earthquake. Seismology is the branch of science that deals with the study of seismic waves. Scientists dealing with the study of seismic waves are called seismologists. The intensity of earthquake is measured in Richter scale. Seismic waves formed as a result of earthquake are classified into three: primary waves, secondary waves and surface waves. Among these, primary waves travel fastest. Secondary waves are slower than the primary waves. In a seismograph, the difference in the arrival time of the primary and secondary waves can be used to determine the approximate distance to the epicenter. The amplitude of the waves obtained using seismograph determines the intensity of an earthquake. Two surface waves, Rayleigh waves that travel only through the Earth's surface, and Love waves are also formed as a result of earthquake. Surface waves are the reason for major damages caused by earthquake, though the speed of surface waves is less than that of secondary waves. Tsunami. Tsunami is a series of gigantic waves in a water body caused by the displacement of large volume of water in the deep regions near the seabed. Tsunamis are caused by underwater earthquakes, volcanic eruptions, meteorite impacts and other such disturbances. The term tsunami is coined by combining two Japanese words, su, which means harbour, and nami, which means long wave. In the Bay region, the speed of tsunami ranges from 600 to 800 km per hour and the wavelength from 10 to 1000 km. The amplitude is less in the deep sea, hence tsunami is not felt by passengers in ships. As waves approach the seashore, the trough of the waves rubs against the land. As a result, the speed and wavelength of the waves drop down and suddenly amplitude increases and the coastal region gets submerged. Tsunami height depends on the geographical nature of the coast and the depth of the seabed. As tsunami approaches the shore from the deep sea, the energy lost is not significant. Hence, the magnitude of destruction will be very high. If it is the crest of the wave that first reaches the shore, the waves rise high, and if it is the trough that reaches first, the sea will be in a state of retreat. The system that gives advance warning about tsunami is known as DART. DART means Deep Ocean Assessment and Reporting of Tsunami. So let's see what are the methods to be adopted to escape from tsunami. First one, move to a higher plane, taking the unusual receding of the sea from the seashore as a warning of the approaching tsunami. Don't assume for yourself that the danger is over. Instead, wait for the official announcement. Try to save your life and not your belongings, as life is precious. If caught in tsunami, try to save yourself by latching onto some floating objects. So students, that's for today. Thank you for watching.